Seafloor spreading occurs at divergent boundaries on the ocean floor. As you can see on the map, divergent boundaries are the red lines going through the ocean floor crust. And during these spreading periods, the divergent plates are moving away from each other and magma is bubbling up to the surface, creating new ocean floor. Now, this new ocean floor is what is creating new crust on the Earth, and on different sides of the plate, there could be a convergent boundary where the more dense oceanic crust is being forced under the continental crust, which is putting the old floor back into the mantle, which would then get recycled and possibly then bubbled back up and creating new ocean floor at one of these seafloor spreading sites. This map is an example of the zoomed in area and the topography of the region. As you can see in this map, there are different types of plate boundaries found in the South American region. There are transform boundaries, convergent boundaries, and divergent boundaries, which we are focusing on in this project, which is the red lines, which are where the plates are pulling away from each other.
The existence of earthquakes within the Caribbean plate and the Caribbean itself are a result of plate tectonics that occur from the Mid-Atlantic ridge and the ocean floor spreading. The area that is now known as the Puerto Rico Trench is an area of subduction that results in the Atlantic plate subducting under the Caribbean plate. This also results in a large number of earthquakes occurring along the area that is the Greater and Lesser Antilles. One of the main evidences of seafloor spreading is the reversal in polarity for different bands within the spreading of the new oceanic crust. For areas that are mirrors of each other from the Mid-Atlantic ridge, you see that there are areas that have thicker bands as well as areas that have smaller bands. The areas that have thicker bands mean that the seafloor was spreading at a slower rate than the areas where the bands are closer together and the polarity reverses more frequently. That is an example of how the seafloor was spreading more rapidly and the poles were changing more and more often.
One of our peer-reviewed articles that we studied for our project today was Convergence of Tectonic Reconstructions and Mantle Convection Models for Significant Fluctuations in Seafloor Spreading by N. Coltis, M. Sutton, T. Rolfe, R. D. Muller, and P. J. Tackerley. And in their article from 2013, they discuss recent types of technologies that have been able to give a better understanding of tectonic plates and seafloor spreading and continental drift and how it's evolved over geologic periods of time. The recent development in geodynamic modeling approaches is a plate reconstruction model, so they can have a better understanding of the chematic reconstructions and geodynamic models that are able to be produced. And in this article, they were able to get better models, as you can see in the image of how seafloor spreading takes place and how it has contributed to continental drift over time.
For my research article titled Asymmetric Continental Deformation During South Atlantic Rifting Along Southern Brazil and Namibia, it discusses the breakup of the continent of South America and Africa during the breakup of Pangaea, specifically during the breakup of Gondwana during this time. It discusses the overlap between Africa and South America and when they are placed next to each other with their current land formations, the discussion that they do not match perfectly because of growth in continental South America, particularly in the Patagonia region, as well as the shift that discusses how both of the continents came to be in their locations.